Question number 7. We have a graph here, 0 to pi of x sine of x. Beautiful. The trapezoidal method, step size of pi on 3, so that'll give me 1, 2, 3 of them. Okay, so the area is going to roughly equal the width pi on 3 times a half, and it will be of f of 0 plus 2 lots of f of pi on 3 plus 2 lots of f of 2 pi on 3 plus 1 lot of f of pi. And I know that that will be pi on 6. That will be 0 because the y value there is 0. And that will be 0 because the y value there is 0. F of pi on 3 is equal to pi on 3 times the sine of pi on 3. And that is pi on 3 times root 3 on 2, which gives me root 3 pi on 6. And I want 2 of them. Root 3 pi on 6 plus 2 lots of. I want to do f of 2 pi on 3, remembering that 2 pi on 3 is in the second quadrant. So that will give you 2 pi on 3 times the sine of 2 pi on 3. And that will be second quadrant, therefore sine is negative, but it's going to be the same answer, so it's going to be 2 pi on 3 times negative. No, it's going to be positive, because sine's positive in the second quadrant, and it will also be root 3 on 2, and the 2's will cancel to leave you with root 3 pi on 3. Which gives you an answer which is pi on 6 times, that's root 3 pi on 3 plus 2 root 3 pi on 3, which is 3 root pi on 3, which is root 3 pi. So I've got pi on 6 times root 3 pi, which gives you root 3 pi squared on 6 square units is going to be the answer. Find the derivative. So we have x sine of x. So f of x equals x sine of x. So u equals x, u dash equals 1, v equals the sine of x, v dash equals the cos of x. Therefore, f dash of x is going to be sine of x plus x cos of x. And over the page, determine the range of the derivative over this interval. From pi on 2 to 2 pi on 3, from about there to there. So it's going to be very steep. It's going to get less steep. Okay, so I have my derivative is something that they are sine x cos. So f dash of x equals sine of x plus x cos of x. So I'd like to find the derivative at pi on 2, and that will be the sine of pi on 2 plus pi on 2 times the cos of pi on 2, which is 1 plus 0 or 1. And that makes a bit of sense because it looked as if it was the steepest gradient there. And if I do f dash of 2 pi on 3, it will be sine of 2 pi on 3 plus 2 pi on 3 times the cos of 2 pi on 3. That's going to be positive root 3 on 2 plus 2 pi on 3 times negative a half which gives you root 3 on 2 minus pi on 3. So I'm going to say 1. This is going to be smaller. I'm going to say going up to 1 and negative root 3 on 2 minus pi on 3. Positive root 3 on 2 pi on 3. Verify that f of x has a stationary point. So hence, I'm going to use this last answer. So if it's going to stationary point in between here and here, then a 0 must sit in here somewhere. So one of these is positive and one of these is negative. So let's check root 3 on 2 minus pi on 3. Pi is roughly 3.14. Therefore, pi on 3 is bigger than 1. And root 4 on 2 is equal to 2. No, is equal to 1. So root 3 on 2 is less than 1. Since that's the case, therefore, root 3 on 2 minus pi on 3 is negative. So somewhere in the interval, the gradient has to equal 0. Okay? And the last part of the question asks me to graph the derivative. And they tell me that at negative 1.1, it's negative 1.4. And at 1.1, it's 1.4. And I know that it is 1 at pi on 3. Pi. And, okay. And what else do we know? So if I wanted to work out the derivative at pi, it's going to be sine of pi plus pi cos of pi, 0 minus pi. Cos of pi is going to be, well, negative 1. So that's minus pi. So we are down at pi and minus pi, we're down here. And f dash of minus pi will be sine of minus pi, which is 0, plus minus pi times the cos of minus pi, which is negative pi times negative 1, which gives you positive pi, 3.14. And we're going to be partly symmetrical. And somewhere around about here, I'm going to have a gradient of 0. So I think that our curve might look like where the endpoint is minus pi minus pi, and it'll be symmetrical, so that will be minus pi and pi. And these will be open circles, because the derivative doesn't exist on the endpoint. And that's that.